Hello, everyone. Happy Wednesday. Hope you are having a great day. Um, hopefully it's still morning. Hopefully you actually are doing this in the morning, or you didn't sleep all morning. Um, I went into so I'm recording this on Tuesday. I actually went into my classroom today. It was weird going into my classroom. It's really empty. All the lockers are getting emptied out and in plastic bags at the foot of the lockers. But went into my classroom, closed it up. Kind of sad. Um, I'm gonna miss you guys. You guys are a good class. One of my favorite classes. You've just been a great year. But that's just the way it goes. We got a week and a half, and so we're going to finish strong. Hopefully, you guys are doing okay with the Pythagorean theorem. We've been practicing a couple days. We got one more day of practice today, and today's lesson should be fairly short. Well, all right, I quit. I keep saying that, but not necessarily. We're going to do a couple problems, but they're going to be word problems. Now, again, you need a pencil, a paper, and a calculator. Please have a calculator with you. Your homework is on a worksheet, so you can print that out, or you can do it from the worksheet. But we're going to do some drawing here. Ready? Okay, let's begin here. Now, before we get started, I do want to, actually, I should plug this in. I want a blank screen here because I just want to review the Pythagorean theorem. And here is what the Pythagorean theorem states. On any right triangle. Now, by the way, if you are struggling with this, some of you have actually emailed me and told me you're struggling, and that's okay. That's cool. Please write this down if you are struggling with this. And this is Pythagorean theorem. So actually, I'm going to stop right there. Can you spell it correctly? Can you, without looking, without cheating, can you spell Pythagorean theorem correctly? Probably not. I want to see if anyone can do it. So if you can, maybe drop me a note or send me an email saying I was able to do it. Just curious. Pythagorean. And then here's actually where a lot of people mess up. Theorem. Theorem is a weird word. By the way, this is a proper noun, so therefore it should all be capitalized. Okay, but Pythagorean theorem states the following: on any right triangle, A with sides A, B, and C, where A and B are the, what do we call those things? They are the legs. And C is the, again, one of those funky, can you spell it words? Hypotenuse. Hypotenuse. Okay? Where A and B are the legs and C is the hypotenuse, the Pythagorean theorem states that A squared plus B squared equals C squared. That is a review of the last couple of days. If you can know that and memorize that, then you should be in pretty good shape with all these triangles. And all we do from there is just a repetition of this process that we're learning of that we're using on how to do it. Okay, so A squared plus B squared equals C squared. Let's just remember these two have to be the legs. They have to be the two shortest sides. And this one here is the hypotenuse. The hypotenuse is always opposite the right angle, and it's always the longest side. Okay, so let's actually put that into practice here. Okay, we got a word problem here. We're going to try it out. Scott and Mark are rock climbing. Scott is at the top of a 75-foot cliff. Whew. He throws down a 96-foot rope down to Mark, who is at on the ground below. If the rope is stretched tightly from Mark's feet to Scott's feet, hopefully he doesn't yank the rope and knock Scott off the cliff, because that would be bad. But anyway, how far from the base of the cliff, directly below Scott, is Mark standing? Draw a diagram and label it. Then find the missing length. Now, what I want to point out here is that the diagram I'm looking for is not perfect. I'm going to do a stick figure diagram because that's what I do. Stick figures. Okay, so I want you to really try to do this problem on your own and try to figure out. First, I want you to just try to draw it. So, can you draw an illustration of this problem? So on your scratch paper right now, just draw it. Pause the video, draw it. When you're done, unpause it. Okay, let's give it a shot. So here is my cliff. Woo! Okay, and here's, which one's at the top? Scott. Here's Scott. Beautiful. I don't know he's dancing or something. He's got the hips over to one side. Anyway, he's dancing. This cliff, oh, how tall is the cliff? 75 feet. Now, not all cliffs are exactly like this, but this cliff seems to drop straight down. Now, he had a 96-foot rope Now that rope is stretched tightly from Mark's feet to Scott's feet. So here's Scott's feet. And they drag it down, and I don't know why Scott is so gigantic. Oh, Mark is so gigantic there compared. This is a 75-foot cliff. What is he, like 30 feet tall? Anyway, work with me here. There is Mark, and this is a 96-foot rope. Well, ladies and gentlemen, look at the picture. And you're like, oh, this is so silly. Yeah. But you know what? Actually, people have used the Pythagorean theorem for a lot of things. In fact, even the Egyptians a long time ago used the Pythagorean theorem, the concept of the Pythagorean theorem, to remeasure their define their plots of land after the Nile flooded. Every year, the Nile would flood and completely wipe out all the markings of the farm and the property line. And so the Egyptians would use a concept of the Pythagorean theorem to make a right triangle. So guys, this is actually a really important thing. This, if we'd said it goes straight down, we could actually calculate any of these measurements. And so this is a good skill to have. And a lot of carpenters actually use the Pythagorean theorem. A lot of people, and anyone who knows a carpenter, ask them. Okay, so here we go. A squared plus B squared equals C squared. Now, again, I'm going to do this one with you. The next one you're going to do on your own. What is A? Well, actually, let's take a different way. What is 75? 75. Is it a leg or is it the hypotenuse? It is the leg. So let's take that one for A. 75 squared plus. Well, what is 96? 96, it's across from the right triangle or right angle, so that is the hypotenuse. So we don't know B squared. We're trying to find a leg, but I know this would be 96 squared. So now I take my calculator and let's find it out. 75 squared would be 5,625 plus B squared equals 96 squared. That's going to be a huge number. Well, not as big as I thought. 9,216. Now, think algebraically. How do I solve this problem? Okay. Well, to get the B alone, first thing I do is subtract 5,625 from both sides. So I subtract that. That cancels it out. And 9,216 minus 5,625. So B squared equals 3,591. Now again, I want the B alone. So to get the B alone, what I've got to do to cancel out squaring something is to do the opposite, which is called the square root. That cancels that out, and then whatever I do to one side, I've got to do to the other side. So on your calculator, again, please find the square root of 3,591. And I want you to round to the nearest hundredth. Now, there is the answer right there. What is that rounded to the nearest hundredth? Well, it'd be 59.92, because the number after the 2 is a 4, and that means it doesn't round. So B is equal to 59.92. We're talking about feet. Okay? And that would be your answer. That would be the distance between the cliff and Mark's feet. Now, some of you are like looking at this and saying, wait, that can't be right, because look at this. You're saying this is 75 feet over here, and then this side that's longer is 59 feet. How can that be? Guys, with these shapes, I want you to be careful, because a lot of times the drawings aren't to scale, not even accurate in this case. And of course, I just sketched it. I wasn't sure exactly how it would look, but you go with the numbers and you use the numbers. Now, if I knew these numbers, if I knew these the two legs, then I could draw more accurately, because then I just connected with the hypotenuse. But I didn't. So that's what we got. Got it? All right. Well, guess what? This next problem is a Pythagorean theorem problem as well. And so I'd like you to pause. Well, let's read it, and then I want you to pause and try it on your own. Jack had a tree in his backyard that he wants cut down to ground level. He needs to know how tall the tree is, because when he cuts it, it will fall towards his fence. Jack measured the tree's shadow. Ooh, this is cool. You can actually do this. And the shadow measured 20 feet long. At the same time, Jack's shadow was 12 feet long. Jack is 5 feet tall. how tall is a tree? Will the tree hit the fence if the fence is 9 feet away? This is kind of an elaborate problem. There's a lot of things going on here, okay? And so we're going to problem solve a little bit before I let you try it on your own. If you do want to try it on your own, you're welcome to go ahead and pause the video now and try it, and then unpause it when you're done and see if you got it right, okay? For the rest of you, let's work some of this problem out together. Okay, so Jack's shadow is 12 feet long. Jack is 5 feet tall. So if I had Jack right here, here's Jack. He's 5 feet tall. Boom, boom, 5 feet tall. And his shadow is 12 feet long. Well, guess what? From his eye, or from the top of him to the shadow, what have we made? A right triangle. 5. The shadow is 12. Okay? So we know that. Now, here's the thing. At this point, do we really need to know that? Are we looking for that information there? Not necessarily. Let's go for the tree. Here's the tree. Woo! Beautiful tree. And the tree, we don't know how long the tree is, but we know the shadow of the tree. Shadow of the tree is 20 feet long. So the question is, how tall is a tree? Now, this is interesting because what do you notice here? This isn't really a Pythagorean theorem practice. A problem. We can actually solve this a different way. This is more like a proportion. 5 over 12, right, equals, and what would go on the other side? Well, x and 20, but where would x be, up here or down at the bottom? X should be with its matching or corresponding side, so it should be at the top. So x over 20, and then I solve it. So let's see. If I do this right here, and I say, okay, well, these two are congruent to these two. So 5 times 20 is equal to 12 times x. 5 times 20 is 100. 12 times x is 12x. I divide by 12, and I get that 100 divided by 12. What's 100 divided by 12? 8, and 3/10 with the bar notation repeating equals x. That means a tree is 8 and 3/10 with the bar notation feet tall. Will it hit the fence that is 9 feet away? No, it will not. Okay. So I'm sorry, guys. I didn't make these slides. That is not a Pythagorean theorem problem. I mean, we could figure out how long this side is if I use Pythagorean theorem, and then just leg, hypotenuse. Okay, I could do that, but I don't need to, so I'm going to stop right there. Ladies and gentlemen, one last problem. Now, this one is kind of interesting here. This is a coordinate point problem. So if you have some graph paper, I should have had you have some graph paper. I'm sorry. If you have some graph paper, please get it out, and let's try this problem. Okay. Graph point 4, 2. So 4, 2, and point -2, 6 on a coordinate plane. I almost did it for you. So if you could please plot those 2 points and then use the Pythagorean theorem to find the distance between them. Well, let's plot them first. So please go ahead and plot those 2 points. When you're done, unpause it, and then we'll do it. Okay, I hope you did it. Let's see. Point 42 would be right there, and point -2, 6 would be right here. Now, the crazy thing is, if I connect these points, whoa, some people are like, well, that's 1, 2, 3, 4, 5, 6 long. No, we have no idea how long that point is because it's at a diagonal. When things are at a diagonal, guys, we cannot find their distance, okay, by just counting squares. That just doesn't work. Now, the problem said, use the Pythagorean theorem to solve or define the length. How on earth could I do that? So if you want to try it, go for it. Try it on your own and then unpause it and let's see if you're right. Okay. All right. Well, I actually remember the slope triangle. It's kind of going to be the same thing. I'm going to make a Oh, I still have it on eraser. That's not good. Let's go back to pen. Here we go. I'm going to make a triangle out of this problem right there. And as you notice, what type of triangle is it? It is a right triangle. Okay. And so do I know my side lengths? Yeah. Hey, this one is 4. This one is 1, 2, 3, 4, 5, 6. This is 6. And this is 4. Oh, so now I just need to find x. So a squared plus b squared equals c squared. A is, I don't know, let's go with 6 squared. B is 4 squared. It doesn't matter which one is A, which one is B, as long as they are the correct, as long as they're both legs. 6 squared is 36. 4 squared is 16 equals c squared. 36 plus 16 is how much? It would be 52 equals c squared. Then, how do I get c alone? I get the c alone by doing the square root. And whatever I do to one side, I got to do to the other side. So those cancel out. The square root of 52. It's going to be some crazy number or some weird number, but let's try it. Square root of 52. Oh, it's going to be a rational or irrational? It's going to be an irrational number because it doesn't terminate, it doesn't repeat. Okay, there is the actual answer right there. So rounded to the nearest hundredth, that would be 7 and 21 hundredths equals C. So this distance right here is 7 and 21 hundredths. Okay, units or squares. And that would be the answer. And using the Pythagorean theorem, we can find the distance between any two diagonals or any diagonals that end at coordinate points that we can actually, use Pythagorean theorem for. Okay. Okay, ladies and gentlemen, that is it for today. Kind of a shorter video, hopefully. Work on the homework. Tomorrow we're going to kind of move on a little bit from the Pythagorean theorem. So we're almost done with this chapter. And so we are finishing up. Again, we got this week and then next week is it. So expect some quizzes. Again, you're going to have a quiz on this Friday and then probably one more next week. So if you are having struggles, please make sure you check on YouTube, check with a friend. Check on Khan Academy as well. That's a pretty good place to go to. I'll also be emailing here shortly any parents of kids who are still missing homework. So if you are missing homework, please go back and check. Some of you are missing from a long time ago. Some of you just are missing one thing and you just need to take care of it. Just make sure you check on that, please. Okay? All right. Have a great day. Oh, I almost forgot. But I didn't. Today is Aubrey Travis's birthday. So Aubrey, happy birthday. Hope you have a wonderful day. I'm sorry I can't give you an Oreo, and I'm not going to sing for you, but happy birthday. Bye.